Now we start section 2, customer retention rate. First, we want to know how many customers we are selling to through time. We want to slice the number of the customers by months. One way is to bring in the customer key from the sales table to aggregate and then do a count over that. Another approach is to leverage table filtering and apply the filter on the sales table. To do this, we count only customers which have sales and wrap the calculation inside the calculate function. Sales table is being used as a filter parameter in calculate function. The filter context contains all the columns of the expanded version of sales. It counts customers in my entire model because sales is a fact table and all the tables have relationship with it. Let's bring it into the visual. I get the same result. I will be pleased to answer your questions before going further. Can we count customers in customers table? No, it doesn't give me the correct result. Let's build a measure to count customers to see what happens. I name it wrong customer count, distinct count, customer key. And drag it into the visual, we are getting the same result. For every month, we just running distinct count over the entire customer table. The problem lies in the fact that the date table in our model has no relationship to the customer table. The only relationship that exists for both of these tables is with the sales table. Consequently, whenever a filter is applied to the date table, it doesn't affect the customer table during the execution of the distinct count function. Now, for each month, we are interested in getting the number of the customers up to these months. I built a measure that computes the running total of customers in the current filter context, filter by months. I created a variable to retrieve the last state of the current context I am on, and I need to remove filters on the date table from the current query while retaining filters coming from outside, if they exist. The if statement is used to count customers, but only those who have sales. In our scenario, we have one filter context generated by the visual. All selected removes filters placed on the date table coming from the visual, but keeps outer filters placed on the date table. Calculate place a filter on a date to be less than or equal to the current date. This filter condition will ignore any filter conditions except the outer filter condition that add a new condition on date. Next, we want to create a measure to track new customers within the dynamic period. We classify customers as new customer within the specific period if the total amount of their purchases during that period matches the running total sales they have made since their initial interaction with us. We should also count customers who have sales within this period. The measure first defines a variable that contains the last date visible in the current filter context. For each month, if the sum of sales until that month is positive, I want to retrieve the number of the new customers. The filter function creates a subtable from the customer table, and a new column called sales selected period will be added to the customer table. This column references the amount of the sales in the current period. If the starting value is 12 months, the dates in period function retrieves all the dates from the date table starting from 12 months before the last date of the current context. We make the value negative to go back one period in time. Based on the slicer value, the amount of the sales in this period is calculated. We then filter down this virtual table and count customers who have spent an amount greater than 0 during this period. The amount of sales in this period should match their overall sales. Lost customers are those who have made purchases in the past but stopped doing businesses with us in this period of time. We have the same code for returning customers, but to retrieve the count of returning customers, we apply a filter to this virtual table. We count customers who have spent a positive amount during this period, and the total sales from this period are less than their overall sales. Now we build measure to get the churn rate. To retrieve the start date, we use EU months, which returns the dates of the last day of the month, one period before the last date of the current context. Then we define a variable to retrieve the number of the customers we had at the beginning of the time period and provide it with a name, a start date customer. These measures use if function to check the number of the customers at the start of the period in order to avoid divide by zero error. To get the retention rate, we divide number of retaining customers by the number of customers we had at the beginning of this period. By subtracting the retention rate from 1, we obtain the churn rate. Now we can analyze the retention rate for a 12 months period. The chart shows that over time we have been consequently achieving high customer retention rate, indicating that our business is serving customers well. Among all countries, customers in Australia are returning for more purchases compared to others. The next visual I have is a line chart showing churn rate over time by country. I don't want to down to the day level, details months is enough. As we can see, the customer churn rate of all countries improved through the year, reaching its lowest point in May 2020. We can say that the company is returning more of its customers, which is generally a positive development for the company. But the company is losing more customers over the course of the next months. Next, we break down customer retention rate by country and category. The report reader can dynamically update the visual to see churn rate by country and category. The charts show that among all countries, Canada generates the least amount of sales, accounting for 41% of the total churn.